Remember that I started some of this by using the term decision criteria, where we are setting up the criteria by which we can make this decision. So I decided, as it turns out, to pass on this investment because Mario was right. It calculated out at 20.28, but Kylie wanted 22 for it. I just wasn't willing to pay a greater price than I thought it was worth, okay? So I passed on this one. How did I make that decision? So I have a set of criteria I made that decision on. Now, I used this model to do it, okay? And in this model, I've got a lot of information here, which today might seem a little complex to you, but inside of a couple of weeks no longer will. This will seem pretty commonplace to you. Let's say that Mario then came to me and said, well, okay, fine, Rick. What do you say we invest in one of these wind turbines that generates electric power out in Wyoming? In fact, we have a business that uses a lot of electric energy. And Mario's convinced me now to buy a wind turbine to generate some of our own electricity. And he and Shenzhen and Diana have put together numbers saying that if we invest in this, we're going to have so much saving in electricity that it's going to give us these cash flows, so savings, if you will, of so much per year for each of the next number of years. I can take the present value of the sum of all of those cash flows. I can add to it then what we might be able to sell that wind turbine for in 5 or 10 years. A salvage value, a scrap heap value, whatever it happens to be. I can add that to it, and that then is and I can discount all of that back to today, and it's going to give me a sense of its present value to me today based upon my discount rate or my opportunity cost of money and time. And whatever that number is, I should be willing to pay that amount for it. But if you guys come to me and say, Rick, it's going to give us a present value of 30, then I won't pay more than 30 for it. So we need to think about what it means when I pay 30 versus what it means when I pay less than 30 versus what it means when I pay more than 30. So in those time value videos and in the prior classes you've had, you've been introduced to the concept of internal rate of return and net present value, right? You may not remember how to calculate them, but you've been exposed to them. So I'm going to walk through and show you how to calculate them in Excel, rather than algebraically and rather than simply with the time value calculator. Okay? So you'll notice that not only have I given you this multi-columnar structure, which looks very similar to the structure I'm using for my valuation modeling part of the templates we're building, I've also given you another set of values here that look a little similar but not. Same cash flows, same present value of those cash flows. But here in this year, it gets all wacko. And I'm putting in here a negative dollar value as a cash flow. What I'm beginning to build is a net present value construction. Well, what's a net present value? It's the present value of all of my benefits minus the present value of my cost. So if there's a proposed investment cost here of 20, and if these are the cash flows, and these are the present value of those cash flows, and if this somehow embodies the next cash flows and the rest of the cash flows, which we'll look at very closely in a moment, then I'm going to take the present value of all of these and subtract from it the present value of the cost of investing in it, and it gives me a net present value. The present value of the benefits minus the present value of the cost, so a net gives me my net present value. Does that make sense?
No.
Okay.
But
Well, let me come to this next line first, and then maybe it will.
Yeah.
Okay? We come to the next line first. Let's do this first, though, Matt. Matt, I'm gonna give you $150 in a cash flow. Okay?
Okay.
And it's coming from an asset worth $50. So if you got the cash flow and you sold the asset, you'd have the sum of $150, right? No, you have a sum of $200. $150 in the cash flow plus $50 in the asset's scrap heap value. Would that be right?
Sure.
150 plus 50.
Yep.
Okay? But I get that in a year. So we're gonna discount it back to today. Let's say that when we discounted that 200 back to today, let's say it came up with 180 when we applied some rate to the end of the year. Okay? So its present value is 180. Mandy, though, offered this investment to me at a cost of 150. So if the present value of the future cash flows is 180, and Mandy offers it to me at an investment or a cost of 150, what's the net present value? What's the difference between the present value of the future cash flows and the present value of my cost? The net. We've netted the cost out against the benefits. So that's how you have to think of this next part of the construction, so we can calculate a net present value and an internal rate of return, because they're part of our decision criteria. Let me walk us through this. I think you understand where I'm getting all of these numbers. You're a little squishy on this 24.4, but if I tell you that it is the cash flow at time 1 divided by the discount rate minus the growth rate, you recognize that as a Gordon growth construction. And I tell you we're going to take that number's present value by taking the number, dividing it by 1 plus the discount rate to the power of t, and we're going to then add this present value and this present value to get this present value. You can easily say, well, if that's the present value, and if it's going to cost 20, well, the present value of the benefits minus the present value of the cost is going to leave us with a net present value of 20.28 minus 20 is 0.28. That's why right here I say the present value of the benefits minus the present value of the cost. That's the net present value. Okay, well that was easy enough because we came up with the present value of all the benefits of the future cash flows, and if it's going to cost us 20 and it's going to cost us that right now, what's the present value of something right now? Well, it is that number right now because there's no time to discount it if it's right now.
So would you, so just in the kind of like speaking in like layman's practical terms, so basically you do all this evaluation, you say, okay, the value is 20.28 and I'm willing to pay 20 for it, and whoever's selling it says, yep, that's a good deal for me, I'll take the 20. You have that 0.28 net present value. How do you, like, how is that looked at from a standpoint? Is that just
the number in your head?
Premium?
Kind of. Keep the number in your head. It is a net present value, or what we're saying is the present value of what you got is greater than what it cost you by 0.28, right?
Okay.
So it means you're going to get a little bit more of a return than you were expecting. If the net present value was 0, and I cause it to be 0 here real quickly. If the net present value is 0, it's because the present value of the benefit and the present value of the cost were the same number. Right?
Right.
So the net present value is 0. Well, what does that mean to us in terms of the return that we get? Well, the return that we get is the discount rate, which is our opportunity cost of capital. It's the return that we required. It's the return that we calculated. So when the net present value is 0, the return we got was the discount rate, or exactly what we required.
So in theory, in theory, if you were just to hold on to your money or whatever, you would earn the same amount, like if everything went according to this model.
If we held on to our money, Michael, and if we were able to get the return for that as we held on to it that we normally get, which is our discount rate. Exactly. Good for you. Well, I'll take this back to 20. So here we see a net present value of 0.28. And that's just by using the equation, one of these values minus the other. But you'll notice I've got the same value 3 times here because there's 3 different ways of calculating it. Some very simple algebra, an Excel function, and then some slightly more complex algebraic functions. So I want to walk you through each one of them. Okay? So Excel has a couple of problems in the midst of all of its brilliance. I would like to use an Excel function that lets me find the present or the net present value of this group of cash flows with this cost. In order to do it, I have to line it up so that the cost at time 0 is followed by the cash flow at 1, followed by the cash flow at 2, 3, 4, and 5, and so on, without interruption and without moving across the cells. It's got to be in a nice, neat column. So this next column here is that. But notice that I have avoided discussing with you so far this 27.25, which probably makes absolutely no sense at all. What might that 27.25 consist of? Any ideas?
Wasn't it just your 20 plus all those 4 cash flows?
It's not. I'll tell you that it includes this cash flow at year 5. But it includes something else as well. What else might it include? Do we have any other number on here that is reflective of a value as of 2024? Is it Michael Schwartz? Pardon, Diana?
Is it 20.28 value FCF?
It's not. It's not 20.28, but you're close. Closing in on it. Michael Schwartz, do you see?
Continuing value?
Yes, Kate, it's my continuing value. What point in time is that continuing value as of? At what year is that a present value? Well, we decided that the continuing value was some value at time 0 being equal to some cash flow at time 1 divided by discount rate minus G. Well, if this continuing value is based upon time 1's cash flow divided by WACC minus G, then what year is its year 0? 2024, the year before. So this is a present value in 2024. So I take this present value in 2024, I add to it this present value in 2024, and that's how I got that number. We need to remember, though, why this number is important to us. Not just because I said or because there's a Gordon growth construction here. What does that number represent? Well, we used the Gordon growth model. We took 2.92, or the next period's cash flow. We divided it by WACC minus G in the Gordon growth construction, which means it's equal to all future cash flows that this company could ever have, assuming they start at 2.92 and grow at a 2.5% growth rate in perpetuity, discounted at 14.47. Because that continuing value based on the Gordon growth construction embodies all possible future cash flows as a present value as of that moment in time. When is that moment in time? It is time 0. And if this is time 1, time 0 is right there.
So the continuing value is really, if you flash forward, would be the present value in 2024.
Exactly.
Okay.
So we're going to take this present value of a cash flow plus all of these other present values all combined together, and they become the present values of that moment in time. Well, that's kind of cool. We've got something going on here. I like this.
But you said the 27.25 is the present value?
No, it's present in 2024. Not present today. It's present in 2024.
But it's in the future or in the free cash flow column. I guess I'm confused.
Well, it's a future cash flow. So $2.85 of this in 2024 dollars plus 24.4 cents in 2024 dollars is equal to 27.25 in 2024 dollars.
I think, okay, so so for just my understanding, it's based on that explicit period of time. That's where the explicit period of time ends. So that's when you have to add in to your string of free cash flows. When you end there, you have to add in whatever the cash flow was in 2024 plus your CV.
Yes, because remember that our Gordon growth construction that I'm looking at right here is some cash flow at time 1 divided by a discount rate minus G is equal to a value at time 0, we said. Well, when is time 0? Time 0 is 2000, not 19. It's the year before this cash flow at time 1. That's when time 0 is. So we take a cash flow that is present as of that year, plus a whole bunch of future cash flows amalgamated together to this same moment in time. They're both present as of that moment in time. We add them together, and we're calling them 27.25 because that's what they are added together, but it's in 2024 dollars. We've got to bring it back to today somehow. Okay? But think back through Excel for me. There's a reason that I've got the cost here as a negative, and then all of these positive future cash flows, and I've amalgamated these two, this one and this one. And I want to use a function to do this. And I run into trouble doing that. I would like to have simply said that I've got the equals net present value, and when I do that, it wants to be given a rate, a value, some other value, and so on in a string. Well, I want to try to do that. And I've given it the string, I've got all these present, but I can't pick up this one. I pick up this one by adding it here to the end of my equation. Why is that? Well, let me look and see what would happen if I did it otherwise. Let me say I just simply said equal net present value. That's the Excel function. I'm going to tell it a rate. That's what it wants. It says it wants rate. So I'm going to give it 14.47, comma, and then I'm going to pick up all these, the stream of cash flows, and I'm going to close it down. And when I do that, it gives me 0.24, which is not that much different than 0.28, but it's not 0.28. Do you know why it gives me the wrong value?
Because the equation doesn't take out the investment that you put into it.
Well, I included it, Mandy.
It's discounting the time zero investment.
And how's it? Do you know how it's doing it, David?
Well, it's calculating as if it was time 1, so it's taking
Exactly.
14.47% out of it.
Exactly. Excel does not understand time 0 in the net present value construction. And if you read this article, it will tell you that. Or if you will just believe David and I, it'll save you an hour. Okay? Excel doesn't understand time 0 when it comes to net present value. So you have to take the present, for the net present value, you have to use the function starting at time 1. And then you simply add as a negative or subtract as a positive, either way, the expected cost at time 0. That's what we've got here. And it gives us the same number here. Okay? Well, if Excel doesn't understand time 0 for net present value, then it would make sense that it wouldn't understand time 0 for internal rate of return, doesn't it? By the way, what is the internal rate of return? Conceptually, what does that mean? Do any of you, other than Matt and I'm going to start to isolate you, Matt, in part because you guys need to start sending Matt a paycheck. He is doing some of your work each week as he is the one to step forward to ask the questions. And I'm fine with that as long as you're fine with that because he's doing your work. But I think you either need to send him a paycheck or a Starbucks gift card or something, or you need to step forward so he doesn't feel like he has to do it for you. And you guys can decide this amongst yourselves, okay? What does internal rate of return mean?
Doesn't it just basically look at your return or the profit on an investment that you potentially can receive?
Yeah, Mandy, it's that profit that we've gotten, that excess cash flow over time expressed as a rate when we've included this conception of time with it. Yeah, exactly. Well, we expected to get a 14.47%. Otherwise, we would never have invested in this, right? If we hadn't gotten 14.47%, we would have walked away because that's our discount rate. That is our opportunity cost of capital. I know I can get that investment return at whatever number it is. But notice that my net present value is positive. Well, it's only a little bit positive, but it's positive. When net present value is positive, the internal rate of return, which I've estimated here, I'll show you in a moment how, the internal rate of return is greater than the discount rate. When net present value is positive, the internal rate of return is greater than the discount rate. Let me take this proposed investment amount back to 20.28. I get a net present value of 0, and I get an internal rate of return that's virtually identical, save a rounding issue, to my discount rate. If I paid more than 20.28, let's say I paid 22. I told you a little while ago that Kylie was a shrewd negotiator, and somehow she got me to pay 22 for this thing that I estimated was only worth 20.28. When the net present value is negative, the internal rate of return is less than the net present value, or excuse me, less than the discount rate. So we're developing some rules here. One of my rules is a net present value. I won't make an investment if my net present value is negative. It's okay for it to be 0. I'd rather it be positive. Another decision criteria, another rule, is I won't invest unless the internal rate of return is at least what the discount rate is. Take this back to 20.28. That's another rule that I might have. Okay?
So let's get back to what Michael was saying when I was confused about the net present value, and he was saying, well, the other option, like if it's at 0, you might as well just keep your money, right, and do something else with it, because it's less than the rate, than the WACC, which is the rate you require, right? Isn't that what you said?
Yeah, that's exactly what he said. But I'll couch that differently. I would say that this investment would be worth doing because its return falls into the parameter of the kind of investment that Taylor is used to getting. This investment meets his expectations, so he might go ahead and do this. If it was negative, if it was a negative net present value, Taylor, if your discount rate, if your opportunity cost of money is 14.47%, are you going to invest in this investment? You need to come off of mute.
If what is 14? What was the first one?
If your opportunity cost of money, the rate at which you know you could get when you put money out in the market is 14.47%, And if you had to pay 22 for this investment, would you invest in it?
No.
No, I agree. Diana agrees. Because it results in a negative net present value. When net present value is negative, we know our investment experience, which is internal rate of return, is less than the discount rate, which is our expectation or requirement. It doesn't meet your needs. If your net present value was positive, by the way, I know Kylie thinks she's a good negotiator, but I'm here to tell you, I am Studley at the bargaining table, and you thought you were going to get me at 22, and we walked away at 18, Kylie, and you felt good about it, okay? I felt better because I ended up with a 2.28 net present value, which means my internal rate of return is nicely in excess of my expectation. How did I get that internal rate of return? By the way, just as you can see here, there are equations that we could apply for our various ways of getting net present value. There is no equation that I've shown you or referenced here. It's not on any of the quick sheets. Do you know why that is? Well, there's one of two possible reasons. Either A, I'm mean-spirited, which may be so, or B, there's no singular equation that embodies internal rate of return. Yep, Lisa, it's an iterative process, isn't it? It's an issue of guessing, comparing the guess against reality, guessing, 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 guessing until it gets to a number. So you can't do internal rate of return as basic algebra unless you're putting together a string of linear algebra, matrix algebra, or calculus equations, which you're not going to do, or unless you use your HP calculator, or unless your buddy Excel comes to the table. Notice that we had this whole discussion of why Excel couldn't be set up to get net present value simply by taking all of these starting at time 0 and moving to today. And if Excel doesn't understand time 0 for net present value, it makes sense to us that it wouldn't understand time 0 for IRR, but lo and behold, it does. So when you're using net present value, Excel has a weakness that causes you to have to morph the equation and tack on the cost at the end or at the beginning, either one, outside of the function. But when you're using internal rate of return, which is simply equals IRR, and then you give it the span of numbers. So I'll put it right here, equal IRR, and then I will go ahead and pick up my numbers and close it out. And it's going to give me my internal rate of return. Okay? And if I paid for the investment exactly what its present value was, my internal rate of return would be the same as my discount rate. And again, I see that it's a tiny bit different, but that's because I've got to run this number isn't really, or rather this number is isn't really 20.28. It's a different number than that. So if I went ahead and just replicated that number.
When you say that you would invest, even if your net present value is 0, is that, like, are you saying that because it's just like a personal, or like, a personal decision you would make, i.e. you're making 0 money, but like maybe you're diversifying your portfolio or something like that, like an ancillary decision rather
Good question, Kate.
than nonprofit?
Am I not making any money, or am I making exactly the amount of money I expected to when net present value is 0?
Are you making the same amount of money that you spent by investing?
Uh-huh. But remember, what I spent has to be thought of in a present value term, and what I make has to be thought of in a present value term. So if the present value of all of my future expected cash flows or my benefits is equal to the present value of my cost, what's my net present value?
0.
0. And if my net present value is 0, what is my internal rate of return? It's my
Same
discount
as your
rate.
discount rate, yeah.
So I made that rate of return. It's just not that I didn't make more than my expectation. I made exactly what I expected. No more and no less.
Okay. Because the discount rate is,
It's your opportunity cost, right?
Yeah. Remember,
okay.
you want to think of it as a cost, don't you, Kate?
Yeah.
But cost and return are two sides of the same coin. It's my
Okay.
return.
So I was kind of getting hung up on that too. So I think
Yeah.
the way I started to think about it is just, okay, if it's at zero, it's kind of sixes. Like you either can, buy this company and you get exactly what you thought, or you can go take that money and invest it somewhere else and, get the same amount on it.
As long as the somewhere else credibly can give me my expected return.
Right, with that assumption. But it's not like necessarily a bad thing if it doesn't have a net present value. It's just, like you said, meeting your expectations. So you're not losing out on anything from an opportunity cost, basically.
Exactly. In fact, I'm going to take it a step further. So, Shenzhen, let's make an assumption for a moment that you have, as an investor, you have an expected return on investments of 14.47%. And you have that because your track record as an investor shows you should be able to average that when you invest. You've experienced this. It is your opportunity cost. And you went ahead, though, and you were willing to pay 21 for this investment, which means you ended up at a slight negative net present value and an internal rate of return of 13.51%. But you made the investment of 21 and you were happy with 13.51%. What does that mean? How do we interpret his happiness by having paid a little bit more than we calculated the value as?
I think it's better than nothing.
It's exactly right. It's better than 13. Oh yeah, it's not as good as 14.41. And if it's the only investment that I'm looking at that can bring me close to my expectation, I'm going to do it. But if Michael's putting an investment and Lisa and Mario and Michael Allen are all putting an investment in front of me, and one of them is going to yield a net present value that's slightly negative, and the others are going to yield a net present value that's either a little bit positive or maybe zero, then I'm not going to accept it. But if it's the best alternative I have, given the menu of alternatives, I'm going to take it because I'd rather get 13.5% than not, right?
Or not to like throw another curveball in there, but what if somebody who's bidding on it decided that 10% that you use to base your entire analysis off of, maybe they said, you know what, I actually think it's going to be a different number and I think I'm going to get even more future cash flow out of this. So by, my evaluation, I am willing to pay a little bit more for it.
So you're jumping ahead 2 chapters. I'm going to tell you not to do that because I could go there with you and Mandy will have somebody hit me in the head with something hard. So she's just about done for the evening, okay? But you're exactly right. We will discuss that. So I want you to think about, we're establishing decision criteria, and I'm showing you a set of values that you can think about with this, okay? If I pay more than present value for an investment, I will end up with a net present value that is negative. It doesn't mean that I lose money. It means I make less than I expected or hoped to. Now, if it's negative enough, maybe I did lose money, right? But a little bit of negative, I didn't lose money. A little bit of positive, I made a little bit more than. So let me go back to my PowerPoint, which we diverged from for about the last hour, and hit a few things real quick. All of what we just talked about is embodied in what we're about to just kind of breeze through. We've dealt with present value, we've dealt with net present value, we've dealt with internal rate of return. There's also something called modified internal rate of return. So I told you that the internal rate of return calculations are an iterative series of calculations honing in on a number. And internal rate of return is a term you will use and hear throughout all of investment and all of finance. It is like one of our holy grail or milestone. It's an important number to us. Here is the ugly truth. It's wrong. It is poorly constructed, and it does not mean what you think it means. Okay? The process by which we go about calculating an internal rate of return and the iterations makes a supposition that we reinvest excess cash flows. Sadly, the reinvestment rate that it is assuming is whatever this amalgamated IRR is. So I'm going to go back to my example here, and I'm going to say, well, what if we could get away with paying 12 for this? By the way, Kylie, I'm not that good a negotiator, and you're not that big a pushover, okay? But what if I could? Well, I'm going to then end up with a 30.22% internal rate of return. Do any of us in our right minds believe that I can consistently get 30.22% on investments in the climate that we had before COVID well enough in the midst of it? Not a snowflake's chance in hell, right? To be very honest with one another. Oh, can we find it sometimes? Yes. Is it serendipitous? Absolutely. Desirous? You better believe it. Should we reasonably expect it to be replicable? Not a chance, unless you want to go broke, okay? But I'm going to tell you that if you look at what's called the modified internal rate of return, for which there is a function in Excel, and the modified internal rate of return makes an assumption that we're reinvesting excess cash flows at an investment or a discount rate. And our discount rate we've said is 14.47, and we've said that that's a reasonable opportunity cost of money for us, okay? Then the modified internal rate of return will give us a more reliable value. And the function in Excel is MIRR, or equal MIRR, parenthesis, equal MIRR, parenthesis, and then it tells us, okay, the first thing it wants are the values, so I'm going to give it the values. And then comma, and it wants to know a finance rate. And I'll use as my finance rate my cost of capital. And then it wants to know a reinvestment rate. I got to give it a comma, sorry. Then it wants to know the reinvestment rate. And I'm going to use the same discount rate for the reinvestment rate. So the finance rate and the discount rate are my cost of capital. You could have them be different numbers. For our purposes, I'm having them be my cost of capital because the way I came about that cost of capital, it is a credible discount rate and it's a credible financing rate. And when I close this out, it gives me a slightly different number, 27.13%, which isn't all that different than 30%. But if we're talking millions of dollars, we can drive a subdivision through that, can't we? Billions of dollars, we can drive some small cities through that. Internal rate of return is erroneous, poorly constructed, and has unreliable foundations. Which foundation is that surplus cash flows are being reinvested at this amalgamated rate, which we would say you can't credibly do that. But if we would just go ahead and accept that we're going to reinvest our surplus cash flows at our same discount rate, it will give us a modified internal rate of return, which is slightly less in this case than the internal rate of return. That said, every finance book you're ever going to come across, every private equity firm, investment house, corporate boardroom talking about decision criteria is going to use internal rate of return, and they're wrong. It's a poorly constructed value. I'm going to expect you to know the Excel structure for this because it is so simple. It's equal MIRR, and then you give it the series of values, and then you give it the financing rate, and you give it the discount rate, and you can use simply your discount rate for both of those, okay? Now, if our net present value was equal to our present value, or excuse me, if our net present value was equal to 0, which means our cost of the investment and our benefit from the investment are the same, then internal rate of return and modified internal rate of return are the same number. Remember, it's reinvesting at this amalgamated rate. Well, the amalgamated rate in this case happened to have been the same rate as the discount rate. And I want to change this so that it's exactly 0 for you, so you don't see that slight disparity. Okay? So that makes sense to us. The larger the disparity in net present value, the greater the difference in IRR and MIRR. When the net present value is meaningfully high, like when we paid less for this investment than we should have, MIRR is less than IRR. So our actual investment experience is less than IRR says it is. When we overpay for the investment, we similarly have a big spread, but now it's the other direction. MIRR is greater than IRR when we overpay. MIRR is less than IRR when we underpay. MIRR is exactly what IRR is when we pay exactly the amount we should have.
So just to clarify one difference between IRR and MIRR, the basic difference is the assumption with IRR that you're going to take all those cash flows and reinvest them back, or reinvest them back at a certain rate.
Right. And IRR assumes that rate is whatever is being amalgamated in our discount rate or in our return here, as opposed to MIRR is using a more realistic set of rates.
When you say an amalgamated rate versus a realistic set of rates, like what do you mean? What rates are we referring to?
This is difficult, Matt.
Okay, that's fine. You don't have to go into it if that's complex. I just didn't know if it was a difference between WACC or what it was.
Yeah, for tonight, let's just believe me, okay? Because we're going to play around with this again and when you're more comfortable with it, all right?
But that's the difference, is it's assuming different rates, not, because at first I thought it was assuming you're going to reinvest all the cash flows, whereas MIR assumes you're going to take some of the cash flows and do something else with it.
No,
that's it's just a difference in rates.
They both assume we're reinvesting all the surplus cash flows.
Okay.
One of them assumes we reinvest at this amalgamated rate. I mean, let's look at this. Maybe I conned Kylie here and was able to get her to take 5 for this investment, in which case I have an IRR of 65, almost 66%. None of us are going to believe that's a credible, duplicatable rate, right? But it is IRR. And it's different than MIRR because the IRR equations, iterances, assume we can reinvest at this unrealistic IRR. We can't. Oh, sure. If we have a cost very similar to the benefit, sure, then we're coming in very close, right? Anyway, I want you to think about the construction of this. You'll use the same construction in the second spreadsheet, of course, and that's the Excel assignment for this week. But you'll also find the problem set assignment uses a lot of the same metric. Let's go just a little bit further on the decision criteria, and then we're going to hang up for tonight, okay? So I know you guys have seen a lot of stuff, and you've been great to hang in there. I want to just tell you about a couple of other things, and you're going to see these on the problem set, and you're going to see them in homework and practice homework number 1, okay? You do not see them on the Excel assignment. And that is this concept of payback period, discounted payback period, and profit index, okay? I want to fast forward to a profit index because it's the easiest of these to talk about. A profit index is simply an index we can use as one of our decision criteria. And it is the present value of the benefits divided by the present value of the costs. So let me put up together a profit index. I'm just going to throw it into a cell here. I'll call it profit index. And it equals the present value of our benefits divided by the present value of our costs. And the profit index in this case was almost exactly 1. In fact, if I'd used exactly as the cost, the same number as the present value of the benefit, it would have been exactly 1. Present value of the benefits divided by the present value of the cost. Well, if I was able to get this for 20 instead of 20.28, my profit index is greater than 1. So here's another rule. When the profit index, when the profit index is greater than 1, the present value of the benefits is greater than the present value of the cost, our net present value is positive. When the profit index is greater than 1, the net present value is positive, which means the internal rate of return is greater than the discount rate. When the profit index equals 1, the present value of the benefits and the present value of the cost is the same thing. That means net present value is 0 and internal rate of return equals the discount rate. And when the profit index is less than 1, not negative, but less than 1, then the present value of the costs is greater than the present value of the benefits, the net present value is negative, the internal rate of return is less than the discount rate. In any case, modified internal rate of return is a more accurate estimate of our actual investment experience than internal rate of return. And very few finance textbooks are going to tell you modified internal rate of return. The other two items, payback period and discount payback period, are simple and they're conceptual. Just look here for a moment and notice that I've given myself a summation here, including the costs, including all the benefits. And this lines up with various years, okay? If I simply, and I'm going to give myself another column, and I'm going to take now, instead of summing the present values, I'm just going to go ahead and sum all of the values. So I'll say equals this number, equals this plus this. I'm doing another running total. And this is, I'm just going to call this payback. Okay? So my payback period is the number of years in which it takes my cash flows, my benefits, to exceed my cost. I'm not discounting here at all. I'm just taking the nominal value of my benefits, bless you, Mandy, the nominal value one period at a time, and the number of years it takes me for the nominal value of my benefits to exceed the nominal value of my cost is my payback period. My investment's been paid back. Think of Kevin O'Leary in the Shark Tank. What's the question he asks more than any other? How long is it going to take me to get paid back? This is what he's talking about, a payback period. He's not discounting at all. This summation column is effectively showing me my discounted payback period because I'm doing a running total of the discounted cash flows. And so if I'm thinking about discounted rate and time, then the year in which this turns positive is my discounted payback period. Now in this case, it happens to both happen in the same year, okay? But that's happenstance. So the payback period is just a running total of the nominal values of my cash flows and when they exceed my cost. The discounted payback is the discounted cash flows and the year in which they exceed my cost. And they're all under this heading of the decision criteria. But there's one decision criteria that we haven't even talked about. Andrew, I'm going to ask you to come off of mute for a moment. I know almost nothing about you financially, but I'm going to make an assumption that if you had to come up with $500 million today to invest, that might be challenging for you. Is that a reasonable expectation for me and a reasonable assumption?
Unfortunately, yeah.
Okay, I would agree. Frankly, I can't come up with $500 million either. I mean, we could just sit here and laugh about it, right?
Yeah.
So apparently there's another decision criteria that doesn't include net present value, doesn't include IRR, doesn't include discount rates, nothing. It's, do we have access to enough money to even think about making the investment? I could make an investment today, as so could most of you, of probably $10 without even thinking about it if I wanted to. But I couldn't make an investment of $50 million without thinking about it hard. And I couldn't make an investment of $500 million without taking LSD. It just wouldn't happen, okay? So that barrier, that hurdle rate is another decision criteria. The first one is, can you come up with the money? The next one might be, how long is it going to take for you to get paid back? Maybe getting the money back in a 5-year period is important to you. Maybe it's not. For Mandy, who's yet a little bit younger than I am, I think, just by looking at her, my guess is, Mandy, you're willing to have investments out there for a longer time horizon today than I am, because I just don't have the time. Okay? Maybe Carol, who's young also, maybe she's just so conservative. She doesn't want to keep money out there. It's not that she doesn't have the time. She just doesn't want to risk the time. Payback periods, net present value, internal rate of return. These are all decision criteria. That makes sense? Okay, so I would ask you if you have any questions, and I do want to know if you have any questions, but I know that in fact, you probably have many that are hard for you to simply verbalize at the moment because of the fire hose from which you've been drinking for the last few hours, right? Okay. The sad thing is, we've only spent about half of our time tonight talking about anything new. Everything we've been talking about, you've been exposed to before in your program. We're just by force feeding it in rapid fire succession, forcing it to come back to you. Which is why we're recording these, which is why I do the review session, and which is why I've scheduled the assignments the way I have to build on each other for you. Are there any questions that you'd like to try to ask before we're done this evening? Well, that's what I thought. Okay. All right, guys. Well, look, if there's nothing else, again, I'm going to encourage you, if you haven't watched the Time to Have Money videos, and by the way, I know most of you haven't, you better watch them. And I'm going to invite you, encourage you, beg you to participate in the review session on Monday night. We started at 8:30, if you possibly can. No, excuse me, we started at 9 o'clock, don't we? Started at 9 o'clock. There's any way that you can possibly do so, I think it'll help you. And that you go ahead and work through the homeworks at least a little bit before we go to that session so you know what questions to ask. Okay? And think about how much you should be paying Matt, or if you want to replace him, or if you just want to send him a Starbucks gift card. Fair enough?
I'd only take Bitcoin. So.
He only takes Bitcoin, in which case he tells you everything about his decision criteria. He's willing to, he has a long time horizon. His opportunity cost of capital is unrealistic and it is high. And by the way, he likes to tilt at windmills. Right? I'm playing. You guys have a good night.
Thanks, Rick.
Good night.
Bye-bye.
Thank you.